So the greatest integer function, get a new sheet. We'll do it right here. What are some of the ones we're supposed to compute for part A there? The greatest integer of, was it 3 point, I don't have it in front of me. 0.785. Okay. Right. The question is, what integer is less than or equal to that, the greatest integer you can get? And so I can, instead of putting 2.5, I can put 0.785, and I get 0. What's that? Because you need an integer, right? So what are the possible things we could spit out? 0, 1, 2, 3, 4, 5. You could also spit out -1, -2, -3, -4. What integer is the greatest integer that's less than this number? It's 0. The greatest integer of 2.5 is 2. The greatest integer of 2.9 is 2. Right? The greatest integer of 2.9999, that sounds German or something, huh? Is 2. Because you have to be less than or equal to that number. 3 is greater than that number. Okay, what else are we supposed to do? Give me another one. 5.6? Well, you know the answer to that. Oh. Pi plus 6, the greatest integer of that. Well, sure, because pi is a little bit more than what? 3. 3 plus 6 is 9, so this is 9 point something, right? So it's the greatest integer of 9 point, who cares? Because that's going to be 9. Right?
Yeah.
All right, what's next? Greatest integer of? Oh, let's do a negative number. That's tricky. The greatest integer of -2.001 might surprise you. That's -3. Let's just see if the calculator gets that right. I'm not sure. The greatest integer of -2. Do you understand why this would be -3? Let's draw it on the number line to see. So here is 0, here is -1, here is -2, here is -3, and so, yeah, thank you. I understand why the greatest integer of 2.5 is 2, or the greatest integer of 2.9 is 2, because 2 is less than those. But in the problem I'm talking about now, I'm at -2.001. Well, what integer is less than that? You got to go down to -3. So that's one thing you have to watch with the greatest integer function. Okay. Now, why even introduce this? Well, again, you might see it in the future, like we see absolute value in the future. It's a nice example of a function that is different than other functions in this course. What I want to do to see that is I'd like to sketch a graph. Okay? So I'm going to go ahead and let the calculator help. Oh no, let's not do that. Let's do it by hand. We'll learn more. Okay. Let's input some of the inputs. Well, for example, what's the greatest integer of 0? Sure. What's the greatest integer of 1? 2. As a matter of fact, this function's kind of boring when you put in integers, right? Now, here's 2. When I put in 2.5, what's the output? When I put in 2.9, what's the output? Okay? And so it goes along this line until it gets to 3, and then I better put a hole there and say, well, it jumps up from 3 until it gets to 4. Do you understand what I'm doing?
How do you denote that?
This is how I would denote it. This is y equals the greatest integer of x. It is a function, right? Does it meet the vertical line test? Sure. It's an example of what's sometimes called a step function. I think you can see why. Okay? It's a function that is not continuous. There's a word that you may or may not have heard before, but it's a word that's very important in the study of functions, and we'll be talking more about that later. Continuous. This function, a function is continuous if you could basically draw it with one pen stroke across the page. This one I have to pick up my pen. Do you see that? It's not continuous. It equals 1 for a while, and all of a sudden it equals 2. It never equals the numbers in between. And maybe this is the first example you've seen. Oh, no, that's not true. I remember number 20 yesterday was not continuous. It had a curvy parabola part, and it had a linear part. You see, when you define functions that are piecewise, there's no reason that the function has to be continuous. This first part is a line. This last part is a line. They have different slopes. Actually, you can see that for absolute value. This is the line y equals x. This is the line y equals negative x. They have different slopes. But the absolute value function would be continuous. I could draw it with one pen stroke, but not that one. Would I connect them? Now, I would leave it like this. Because if I start connecting anything, I think it's not going to be a function anymore. You know, the last thing you could do is you could graph, let's see what y equals the greatest integer function looks like on a calculator. So y equals int of x. And I'm going to hit zoom standard, which gives me just the normal. Oh, look at that. You know, they kind of messed up, didn't they? They connected. That's because your calculator is programmed to assume that we have continuous functions. And sometimes when we don't, your calculator is going to screw up. It's important to be smarter than your calculator, okay? Or to learn what it does.